NASA continues the Artemis II campaign despite some shakeup from the latest presidential budget proposal. SpaceX is set to fly a Falcon Heavy, not so heavy. Rocket Lab shares the latest on Neutron's development, and an old Soviet probe may crash on Earth in the coming days. As always, we'll have all that and more coming up this week in Spaceflight. The situation with NASA's Viper mission just got a whole lot more confusing. Viper, which is short for Volatiles Investigating Polar Exploration Rover, was designed to autonomously explore the lunar South Pole as part of the Artemis program. It was supposed to roam around on the moon's surface for 100 days, searching for water ice and other potential resources. The knowledge collected by Viper could then be used to harvest the moon's resources on future human missions. Originally, Viper was to be delivered to the moon as the main payload on Astrobotic's Griffin lander, which was originally scheduled to launch in late 2023. It was then postponed a few times and is currently on the manifest for September of 2025. The Viper will no longer hitch a ride on Griffin. Last year, NASA pulled the plug on the mission, citing cost increases and the aforementioned launch delays. The salient detail in this whole saga is that the rover was already finished and sitting in the clean room awaiting launch. Adding insult to injury, NASA will now provide an inert mass simulator to launch on Griffin instead. But this wasn't the end for Viper, as NASA offered the rover to industry partners. If a company wanted to adopt the rover, it could still be launched to the moon and make itself useful there at no additional cost to NASA. Well, in a baffling turn of events, NASA has now changed its mind once more and canceled the search for a launch partner just a few months after the agency asked for proposals. Instead, NASA will now, quote, explore alternative approaches to deliver its Viper rover to the moon. So I guess Viper is uncanceled now? A mission that won't be cancelled is NASA's Artemis II mission. At least that's what Jared Isaacman said during the confirmation hearing for his nomination as the next NASA administrator. While Jared is still waiting for the Senate to vote on his position, NASA is continuing to prepare for Artemis II. This will be the first mission to fly humans around the moon since Apollo. On board the Orion capsule will be NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, as well as Canadian astronaut Jeremy Hansen. The four have been training for this mission for a while now, and they recently completed long-duration fit checks for their suits and seats. Additional training sessions are coming up to prepare the crew for pre-launch operations and emergency situations. As the crew is getting ready, NASA is assembling the rocket that will launch the mission. On May 1st, teams integrated the Interim Cryogenic Propulsion Stage, or ICPS, on top of SLS in the Vehicle Assembly Building. The ICPS is the rocket's upper stage that will raise Orion's orbit ahead of translunar injection. With the addition of the ICPS, the SLS rocket is now mostly complete. It's only missing Orion, but before the capsule will be attached, NASA plans to test the vehicle and to perform more work on the core stage this summer. Orion will connect to the ICPS using a stage adapter, which will arrive at the Kennedy Space Center later this summer. But this adapter won't just connect the capsule to the rocket, it'll also host some additional passengers. This week, NASA signed an agreement with the Korea Aerospace Administration to fly a South Korean CubeSat on this adapter as an additional payload. The satellite will measure radiation across the Van Allen radiation belts that encircle our planet. It'll do that with a dosimeter made of a material that mimics human tissue to assess the biological effects of this radiation. This is the second such payload that's been announced. Last September, NASA agreed to launch a CubeSat for the German space agency DLR on Artemis II. The German satellite will measure the space environment and its effects on electrical components. This week, the Artemis II Orion capsule left the Neil Armstrong Operations and Checkout Facility, where it was assembled and subjected to initial testing. Its next stop is the Multi-Payload Processing Facility, where it'll be loaded with propellants, coolant, and other commodities needed for the trip around the moon. All fueled up, Orion will undergo even more tests and checkouts, including a test in which the astronauts don their spacesuits and enter the spacecraft to make sure that all systems work together as they're supposed to. Following that, Orion will move to the Launch Abort System facility. Unsurprisingly, that's where the Launch Abort System will be installed to prepare the capsule for integration on top of SLS. With the whole stack complete, NASA should then be ready for launch, which is currently scheduled for April 2026. We have, however, seen some hints that NASA might actually be aiming for an earlier date. Do you think NASA will be able to pull this off? Let us know in the comments. We'll follow NASA's progress on future episodes, so subscribe to our channel if you want to stay up to date with that and other space news. And now onto a mission that's much closer to the moon. Literally. The second Hakuto-R mission from the Japanese company ispace entered lunar orbit this week. On May 7th, the lander named Resilience performed a 9-minute burn, completing its transfer and ending up in lunar orbit. Now you may remember that Resilience has been on its way to the moon for a while now. It was launched on January 15th, together with Firefly's Blue Ghost lander, which completed its very successful mission back in March. But ispace's lander took a much longer route to get there, swinging way past the moon, traveling as far as 1.1 million kilometers from Earth. This trajectory, known as a low-energy transfer, is very efficient and actually saved a lot of propellant. Now, after this week's 9-minute lunar orbit insertion burn, the lander's longest burn yet, Resilience is finally getting close. This completed the 7th out of 10 mission milestones, which ispace calls successes. Still forthcoming is a series of planned maneuvers in lunar orbit, as well as some checkouts ahead of landing. Together, these will mark Success 8. This will be followed by an attempt to land on the moon, which is currently scheduled for June 5th and completes the Success 9 milestone if all goes well. After that, ispace hopes to tick off one final milestone by reaching steady communication and power supply on the lunar surface. The first Hakuto-R mission and some other recent landers have shown that these last two milestones are all but guaranteed, so we're definitely keeping our fingers crossed. And now for the latest on Rocket Lab's upcoming Neutron rocket. The company gave an earnings presentation to its investors this week. These calls usually include some updates on the company's rockets and satellite programs, and this one did not disappoint. The company's been working on a medium-lift rocket with a reusable stage for some years now. The rocket's powered by methane and liquid oxygen and is capable of lifting 13 metric tons into low Earth orbit in its reusable configuration. In true Rocket Lab fashion, Neutron is made out of carbon fiber, but that's not the only reason for its distinctive look. To maximize the number of parts that can be reused, the fairing that protects the payload during launch remains attached to the first stage from liftoff to landing, making the design unlike any other rocket. Teams at Rocket Lab are on the job getting this thing flying, and work is underway on many of the milestones that need to be met before launch. Most of these milestones are being worked on in parallel, and some important second stage milestones have also already been ticked off. As this stage has structural similarities with the first stage, Rocket Lab believes that these milestones have also reduced some risks for stage 1. The second stage for the first mission is now undergoing final integration before it'll make its way to the launch site for engine testing. Neutron's unique first stage actually consists of 2 pieces or modules. While these stay together during launch, they're only mated together shortly before launch. The upper module encapsulates the payload, and the first of these is nearing completion. Last time we saw only the fairing halves being put through their paces during testing, but now the photos in the presentation show a full module. According to Rocket Lab CEO Peter Beck, this is one of the most mechanically complex systems of the entire rocket, and it all worked seamlessly. With the assembly of the first Neutron to fly well underway, Rocket Lab also needs a place to launch the mission from, a launch site. That launch site is Launch Complex 3 on Wallops Island in Virginia, which is now nearing completion. Recently, Rocket Lab tested the water deluge system that protects the launch pad and the rocket from the flames and acoustic energy during launch by unleashing massive amounts of water. Beck says that the equivalent of an Olympic-sized swimming pool flows through this system every 40 seconds. But the rocket also needs a passenger, and with this earnings call, Rocket Lab also announced a contract for one of Neutron's first missions. The US Air Force has selected the rocket to fly a point-to-point cargo mission. This mission is part of an Air Force research lab program to create a system to rapidly deliver defense cargo across the world. As you may have guessed, this requires rockets to fly so-called point-to-point missions, in which they lift off not to deliver cargo in space, but to land at a specific point on Earth where the cargo is needed. Neutron will launch an experiment to prove that the cargo can survive the ride up and the subsequent re-entry. The launch is scheduled no earlier than 2026 and will see Neutron fly in its reusable configuration. According to Rocket Lab, both the rocket and the launch pad are still on schedule for the first launch in the second half of this year. Of course, that's the latest version of the schedule, which has seen some changes over the years. Regardless, they seem to be making steady progress, and we're certainly looking forward to seeing Rocket Lab get ready to launch its first Neutron. On schedule, of course. For the last 3 months, there have been several rumors about what course of action the new presidential administration will take within NASA. Now, with the release of the presidential budget proposal for fiscal year 2026, we can say that a lot of those rumors were true. Now, just a small note on this up front, this is just the short, non-detailed version of the president's budget, often called the skinny budget. The full detailed version of it won't come out until later this month. But that said, it still gives us a lot of information, and according to it, the president is proposing to cut NASA's budget by about $6.3 billion. The majority of cuts center around 3 major items: space science, earth science, and mission support. On the space science front, the cut is of more than $2 billion, and the document states that the administration proposes to reduce and terminate what it calls lower priority research, including the Mars sample return mission. Needless to say, the money that was planned for the Mars sample return mission for the next fiscal year is nowhere near $2 billion, so there are some other big missions getting the axe that contribute to that big sum. Prior to the release of the skinny budget, the rumor was that the administration planned to cancel projects like the Nancy Grace Roman Space Telescope, which is almost complete and gearing up for launch in less than 2 years from now. It's also likely that other missions will not move forward, will be delayed, or will be canceled altogether, which doesn't bode well for the scientific power that NASA has traditionally enjoyed. The budget proposal also talks about beating China at going back to the moon, but meanwhile, China is proposing big flagship missions to other places in the solar system that NASA hasn't even considered yet. So is it really worth it to throw major science programs out the window just for $2 billion in savings? Science is, of course, not the only thing being cut from the budget. As expected, SLS and Orion are also on the chopping block, and the administration is proposing to cut both programs after flying Artemis II and Artemis III. The administration's proposing to shift the budget priorities and to fund a Mars program while also finding commercial, cost-effective ways of transporting people and cargo to the moon. And yes, cancellation of Gateway is also being proposed. There are other things being cut, such as portions of NASA's space technology program with a reference to failing space propulsion projects. I guess we'll have to wait until the detailed budget proposal to know exactly what that means. Another surprising cut is the proposal to downsize the crew on the International Space Station and to reduce the number of cargo missions to the orbiting laboratory. The document also makes reference to the station's research being focused on efforts critical to the Moon and Mars programs. Now, of course, going into detail about all that's on the chopping block would probably take an entire episode, so we won't be doing that here. But we are working on a video all about the NASA budget, how it's been in the past, what kinds of things the upcoming administrator is going to have to deal with, and much more. And as said at the beginning of this story, this is just the presidential budget proposal, so it still does need to go through Congress, and it'll be many, many months until that happens, because budgets take a long time to go into effect here in the US, which means that many of the things proposed in this budget probably won't survive all the way to the end of the process. That said, it does reflect the direction in which this administration is going, and that is going to give us a lot to talk about in the future. Now we'll take a look at some other stories across space, starting with SpaceX's test facility in McGregor, Texas. This week, the company rolled out a new booster, B-1091, for routine pre-launch acceptance testing at the site's booster stand. This would have been just like any other booster, except for the fact that it is a Falcon Heavy in Falcon 9 clothing. When it rolled out in front of our McGregor live cameras, we could see that it had a few different features from a Falcon Heavy center core. For example, it had no SpaceX or Falcon 9 logos on the tankage, and its octaweb has the inserts used to attach the Falcon Heavy side boosters. However, the booster's interstage is black, meaning that it's in its Falcon 9 configuration, hence the Falcon Heavy in Falcon 9 clothing. John Edwards, SpaceX's vice president of Falcon and Dragon, said on social media that this booster is indeed a Falcon Heavy center core, but that the company is going to initially launch it as a Falcon 9 booster. This will allow them to fly it a few times while the Falcon Heavy customer gets ready for their launch. Falcon Heavy center cores are specifically made to support the loads from the side boosters, so they're built with thicker tank walls and reinforcements that make them slightly heavier than a regular Falcon 9 booster. This means that when it flies as such, Falcon 9 will have a lower performance, but if they can get a few more uses out of the booster, that probably makes up for it. NASA's SPHEREx space observatory has begun its mission to map the entire sky and hopefully answer some big questions about the origins of the universe and cosmic inflation. The space telescope launched on March 11th and has spent the last 6 weeks performing checkouts and calibrations. It began its 25-month survey on May 1st and will take around 3,600 images per day over the next 2 years. From its polar orbit, SPHEREx scans the sky in circular strips. 6 onboard multispectral detectors take unique sets of images across 102 wavelengths in infrared light. In the images released this week, these wavelengths were assigned different colors, resulting in a rainbow effect. To receive the several gigabytes of data that SPHEREx collects every day, NASA leveraged an existing commercial partnership to upgrade the Troll Station antenna in Antarctica. This remote station then relays that data through the Near Space Network, where it's stored in the cloud. As a result of Earth's orbit around the Sun, SPHEREx is able to see the whole sky in half a year. By the end of its mission, it'll have created 4 different maps of the universe in glorious 3D. By studying the universe in its largest scale yet, we'll hopefully gain new insights into the first fraction of a second after the Big Bang. Our writer Marty wrote a whole story about SPHEREx for our news website this week. Be sure to check it out to learn more about this mission and its launch companion, Punch. The European Space Agency is proposing to develop a reusable space tug to open up low-cost missions to Mars. The agency has requested proposals from the space community for science payloads that could ride to the red planet aboard its propulsive tug called Lightship. This electric tug would dispatch either a single passenger craft or several smaller ones into a variety of Mars orbits and would then switch to delivering a different kind of service. Orbiting Lightships would provide Mars communication and navigation infrastructure services, or Marconi for short, building their available coverage and bandwidth as additional Lightships arrive. The first planned mission will carry the Spotlight passenger spacecraft with 2 ESA-funded high-resolution imagers on board. The 2 craft have the capacity for around 40 kilograms of additional science payloads, and ESA is looking for proposals to fill this additional space. Suggested applications include the monitoring of atmospheric weather, temperature, and dust cycles. These could inform safer entry, descent, and landings onto the Martian surface and provide a deeper understanding of thermal and power conditions there as we make plans towards a presence on Mars. The broader concept includes multiple missions, driving down cost, and building in redundancy. The project still has a number of preliminary reviews to pass through, but if approved, the first Lightship mission would target a launch date in 2032. The Nancy Grace Roman Telescope, the next large NASA space observatory, has passed an important milestone on its road to space. The telescope's outer barrel assembly and deployable aperture cover were recently tested in the Space Environment Simulator test chamber at the Goddard Spaceflight Center in Maryland. NASA performed these tests to make sure that they could withstand the extreme heat and cold that they'll encounter in the vacuum of space with no atmosphere to even temperatures out. As part of these tests, the assembly sported a test version of its solar array, which doubles as a sun shield. With this test now complete, this test solar array will be replaced with the flight version later this month. But this is just half of the observatory. The other half includes the spacecraft itself with the telescope and its instruments. These parts are already integrated and will go through a test campaign of their own. The 2 halves will be mated in November ahead of launch atop a Falcon Heavy in 2027, or potentially even earlier. Even though budget debates on Capitol Hill may impact its future, it's full speed ahead for the moment on Nancy Grace Roman. In a rapidly changing world, there's a new human spaceflight collaboration agreement between the European Space Agency and the Indian Space Research Organization. ESA and ISRO signed the agreement during this week's Global Space Exploration Conference in New Delhi. Last year, ESA announced that its ground stations would also support India's new Gaganyaan human-rated spacecraft. The first uncrewed orbital test flight for this project is scheduled for later this year, but this week we learned that Gaganyaa's first human mission slipped from 2026 to 2027. In addition to its crew capsule, India is also planning a space station called the Bharatiya Antariksh Station. Its first module is scheduled to fly in 2028, though this might slip as well. This is spaceflight after all. The agreement signed this week could lead to ESA astronauts visiting the Indian space station. Notably, the agencies specifically want to work on interoperability between their rendezvous and docking systems, allowing ESA and ISRO spacecraft to work together while in orbit. What's more, the agreement also allows for astronaut training activities and even future robotic missions to the moon. This week's agreement with ISRO follows an agreement with Japan Japan's JAXA in March to explore joint missions to the Moon and Mars. Space exploration is certainly changing with the times as more countries get involved in what was once reserved for the two Cold War superpowers. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. This was a really rare week with only 2 launches, both of them being Starlink missions by SpaceX. The first one lifted off on May 4th at 8:54 UTC from Launch Complex 39A in Florida, carrying 29 Starlink V2 mini-satellites into low Earth orbit. That was a record number of Starlink V2 mini-satellites launched in a single Falcon 9 mission, mostly thanks to upgrades to the satellites to reduce their mass while maintaining or improving their capabilities. According to SpaceX, these so-called optimized V2 mini-satellites would have a mass of approximately 575 kilograms. This means that with 29 of them on board, the total payload mass was shy of 17 metric tons for this mission. While that's a lot of mass, it's still not the most mass that Falcon 9 has launched in a single flight. That record currently sits at about 17.4 metric tons, so who knows, perhaps future small tweaks may allow SpaceX to even fit in an extra satellite or two. The first stage for this mission, B-1078, was flying for a 20th time, becoming the 11th booster to reach 20 flights. It then successfully landed on SpaceX's drone ship, a shortfall of Gravitas, to be reused on a later mission. The other launch of the week was from Space Launch Complex 40 on May 7th at 1:17 UTC, carrying 28 Starlink V2 mini-satellites into low Earth orbit. The first stage for this mission was flying for a 7th time, and it successfully landed on SpaceX's drone ship. Just read the instructions. Those 2 launches add 57 new Starlink satellites to the total launched by SpaceX, which is now at 8,488. Of those, 1,112 have re-entered, and 6,616 have moved into their operational orbit. Going into next week, we may see a lot more action with SpaceX planning up to 5 Starlink launches, and one of them might even be happening as this episode is being edited. There are also 2 potential launches from China as well, and although this past week we had hoped to see the second flight of the Changzheng 12, it looks as though that's been delayed for the moment. At the end of next week, we may also see Gilmour Space try to launch its Eris rocket from Australia. The company finally had its launch license approved by the Australian Civil Aviation Safety Authority and is awaiting final approval from the Australian Space Agency. Pending that final sign-off, Gilmour's targeting the first launch attempt of Eris no earlier than May 15th, so we'll keep a close eye on that for next week's episode. Next week, we may also have an unusual return to Earth. All the way back in March of 1972, the Soviet Union launched the Venera 8 mission to the planet Venus. Just a few days after that launch, the country launched another mission, which is believed to have been another Venera probe. However, the upper stage that should have sent the probe to Venus shut down early during the burn to escape Earth's gravity and left the spacecraft in a highly elliptical orbit around the Earth. Over time, due to atmospheric drag when flying closer to Earth, that orbit has been degrading, and that means that this probe may come back down sometime next week. Right now, based on the latest estimations and tracking of the object's trajectory, it appears that it may re-enter sometime in the morning of May 10th. Knowing exactly when it might finally re-enter is hard to predict because it depends on the exact mass and size of the spacecraft, the drag that it creates, and even the orientation of the spacecraft. It's very common that as uncontrolled objects encounter slightly thicker air, they may start to tumble, which changes the amount of area presented to the atmosphere, and therefore the amount of drag, which then in turn changes how much it slows down and therefore when it might re-enter. So it's not a surprise that, for now, many of these predictions have really long time windows, even when very close to that re-entry. That also means that we won't know the exact re-entry location until it actually happens. The probe includes a descent capsule that was meant to land on Venus, so there's a good chance that it might survive re-entry, but without a parachute, it may also impact the ground at terminal velocity, and we certainly don't want to be underneath that. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.